Hi, my name is Michael and I'll be demonstrating the Fragile Software Design Test Generation Framework. In this demonstration I'll be running through the steps of how to install and run the project. I'll also go through some of the core concepts that went into creating the framework, in addition to showing an example usage of it. Firstly, to run the project you must install Chrome, Node.js and Yarn. Once those are installed, extract the zip file into the desired directory. Once extracted, navigate to that directory and execute the command yarn. Once yarn has finished installing all dependencies, you can run the project by executing the command yarn start. Once the tool is finished running, you can see the output in the file output.csv. All test set generations happen through a runner class. This runner class takes in a number of members, including seed, an array of generators, a test function, and a key value store. When a test is run, it takes in the number of tests that we want to run, and it will generate values for each of those tests. By using a set seed, we can ensure that all of the values generated for a given test set are deterministic and can be repeated across multiple executions. Once each test is completed, we dump the values within the store into the results matrix. This results matrix is then returned once all tests are completed. All generators are based on this generator class. Generators have a number of members, including the generator itself, options for that generator, and a number of middlewares that get executed whenever a value is requested. Generators can be of different data types, including string, number, and date. All generators have member functions which return self-references. This allows the syntax to have a chaining effect, seen in the index.js file. As you can see, generators follow a chaining effect, going from the root generator factory functions to defining the type and then defining the bounds to which they will be generated. As seen here with the date generation, we first generate a check-in date. Then, since that generation happens before the checkout date, we can reference it. We can generate a date that happens after the check-in date, so that our checkout date follows the logical requirements of being after the check-in date. This string input is a great example of middleware. This garble function applies a middleware to the string that is generated that has a 50% chance of introducing noise into the string. This noise comes in the form of symbols and otherwise unnecessary characters in the context of many string inputs. So, going back to our runner. Our runner is first defined here, then we create our object of generators. Then we have the opportunity to set a seed, which will determine the basis upon which all random generation will happen. We set the generators, applying them to the runner, and then we set our test. Our test function is simply one which takes in the runner object and the key value store. In this case, we've used Selenium to create a functional browser test. We create our WebDriver instance here, and then pass that into functions lower down, including the runner and the store. Then, as seen in this input page test function, the store is destructured to enable access to the generated values. Those values are then used to interact with inputs on the page. In this case, we send our destination input as a series of key presses into an element that will be used by the website to determine the destination. We then use our date values to set the check-in and check-out values on the website, and we then use our number of children and number of adults values to set those on the page also. We submit our search, and then we wait for attributes to become available on the page so that we can assess whether or not a test has succeeded. For example, we must wait for the title to contain the destination input to know that the search has succeeded. We then wait for several more elements to appear which correlate to the values that we have inputted. For example, we look through the returned HTML to try and find an element which satisfies this CSS selector. As you can see, it's trying to look for an option element where the value is the number of adults that we have defined and its selected value is selected. If it cannot find that before 3000 milliseconds has expired, then the call will throw and the test will be unsuccessful. Finally, we can access our runner class, namely the setValue method, and set values within the key value store to determine whether or not a test was successful. Since it is a key value store, we can store any number of variables determining the success of any number of tests. By decoupling the test and the generators, we have created a test case generation framework that does not rely on any one given testing framework. So finally, to demonstrate, I will run the project one more time to show you how this all works. So the values get generated, they get inputted into the input boxes at the top of the screen, and then the result is assessed. And as you can see, the result of these tests can be found in the output.csv file in the root directory. Thank you for listening. Bye.